So it's a pretty nice day out here today. It's about 75, a little humid, but really nice. And despite the fact that I'm not getting any direct sunlight, I'm still generating a little over an amp per hour of electricity, which isn't much DC, but still, it's better than nothing. So each panel right now is producing about a half of an amp DC current, but I'm still able to produce quite a bit of electricity. Here it is mid-July, and despite the cloudier days that we've had, I've still been able to sustain myself as far as electricity use for a lot of things around the home. Now, if you've seen my previous videos, you'll know that right now I am off the grid. And for my situation, that is actually the way it has to be. Because I live in an apartment, I cannot grid tie back into the grid and be credited, basically, or sell my electricity back to the energy provider. It's just not possible. There's so much equipment that's required, and the room that houses all of the meters for the building would not be able to accept that special equipment. So unfortunately, that's just not possible. At the same time, I would not be able to generate enough electricity to actually be credited back. Just the simple fact is that based on my location and only being able to get the afternoon and evening sun, it's not enough electricity to sell back to the energy provider. When you go grid tie and you actually have somebody come out and install the inverter outside that hooks directly to your mains, you are probably looking at least a 2 kilowatt minimum farm on your home, 2 to 5, sometimes even more. It all depends on how much money you invest in it. So it is completely impractical and basically impossible for me to grid tie back to the system that will allow me to sell back the electricity. Now, there is a separate issue with being off the grid. I do have access to the grid, but not access to the mains. Basically, I have access to, the plugs around my home, and I can actually use that to my advantage and actually micro grid tie to the system. And I'll explain exactly what that is. On the left, you will see another inverter that I have. It is a Grid Tie Micro Inverter, and I have it plugged into my kilowatt meter here to monitor my supply basically back into the grid. So essentially what this micro inverter does here, this is an actual Grid Tie Micro Inverter. Essentially what it does is it takes energy from whatever your source is, which for this particular one is solar, but you can buy them for solar and wind or other means. But because I'm only running solar basically for this, then the grid tie inverter is set up for the solar. But essentially the excess energy that I have that's not going into my batteries is going back into the grid. And the reason that I have to do this is because of how I run my off-grid setup, okay? And I'll try to explain that. Basically, my battery, my deep cycle battery that I have, I only run it down to 80% of capacity, okay? So my 120 amp hour, my 125 amp hour battery, I only take it down by approximately 25 amp hours, okay? 25 amp hours converted to AC from DC is only 2.5 watts. That's a perfect one-to-one conversion. You can expect a little bit of a loss there because of the conversion process with converting from DC to AC. There is actually a loss. The inverter that I have right now is between 90 and 95% efficient. So you can look at about another, tenth of an amp maybe. So that 25 amp hours in AC terms does not go too far, but that's, my choice. I've chosen not to bring the battery down any further than that. So when doing that, basically, I only have 25 amps that I have to replenish back into the battery. And from sun up till I hit direct sunlight, I'm usually generating about an amp, we'll say. So for about the first 6-7 hours of sunlight, I'm generating about an amp per hour. So you're looking at about 15 to 20 amps, basically, DC amps that I have to replenish by the time the sun hits the panels. And when that happens, with me generating about 11 to 11.5 amps, it takes just a little over an hour to completely recharge the battery. Now that's if I actually use the battery every day to 80%, okay? So the excess electricity, when the battery is charged, is normally dumped into nothing. The charge controller disconnects the solar panels from the batteries, and the solar panels then go into open voltage. And essentially they're providing electricity, but the electricity is not going anywhere. And that is wasted electricity, completely wasted. Now, most of the time, I'm home when my battery is charged, and what I will do is I will actually turn on my DC to AC inverter. Okay, I'll turn it on. I will plug stuff into it, and I will begin using the energy. So the energy is coming basically in through the batteries and routed up to the inverter, and I'm consuming the electricity that the solar panels are providing, and the battery is staying charged unless I'm using more, which I do. But the point is that energy from the solar panels, even though my battery is charged, is being consumed 100%. The problem is that I'm not always here to consume that electricity. And with 2 kids that are growing up, and after-school activities, and in-laws, and going out to dinner, and all sorts of other things, I cannot be here when the battery is charged. Okay, I only have one battery. I only bring it down 80%, so my options are really limited. So it doesn't take that long for this single battery to become fully charged, and then I begin wasting the excess electricity. So the solution, the big solution to that, is to micro grid tie. And the micro grid tie inverter essentially will take the solar panel energy and convert it into AC, which is then fed back into the grid. Now, I'm not going to get into the ethical or even quite possibly legal, which there is no, currently, right now, there is no specific prohibiting rule from either my energy company or the state of Michigan to do this. However, there's more of an electrical code that needs to be followed, basically. And even though this grid tie inverter is not actually rated by the electrical standards, it still has all of the features that are required by electrical code in order for this to basically be allowed to operate. And I'll get into that in a second, but essentially I'll show you how the grid tie inverter receives its electricity. You can see right here, right now, that it is actually being fed by my solar panels. You can see the green light there. And so right now it looks like about 16 watts is going back into the grid. I know that doesn't seem like much, but the panels themselves are not under direct sunlight. Now, as you can see there, the light went off because my charge controller has kicked back over to start charging the batteries again. or battery. So that energy is now being diverted back to the battery. And in a second here, the charge controller is going to see the battery is full, kick it back over to the divert, and that will start the grid tie inverter again. So it should be starting right here. So you can see the red light comes on. That means that it's in MPPT mode, and there you go. So now it's feeding energy back into the grid. Looks like 13, 14 watts approximately. Okay, that's not much, but again, like I said, this is excess electricity. I'm not under direct sunlight right now, so instead of this energy being wasted, it's actually going back into the grid. Okay, so you can see here, my charge controller right now is in divert mode. That is what this red light means. And previously to me getting this micro inverter, at this point when this red light is on, the energy is being basically diverted into nothing. The solar energy, the panels are basically they're put into open circuit. They're still providing electricity, but they're not doing anything, and the electricity is just not going anywhere. So this became a serious problem because in the afternoon when I was getting a lot of sunlight, battery was charged, this red light was coming on a lot, which means it was going into divert a lot, and that electricity was wasted. 100% of it was wasted completely. It's not going anywhere, it's not powering anything. And it's easy for me to, for somebody to say, well, just turn something on or whatever. But when you're not home, there's no point in having things run just to consume the electricity. You need to figure out how you can use that excess electricity. And it's not much for me, but for somebody who's running like a 1 kilowatt or above system, and they happen to be not home, their batteries are charged, they need to figure out what to do with all that excess electricity, because there's going to be a lot. So it's about to come out of divert mode here. The battery voltage is dropping to the level that the charge controller senses it needs another pulse of electricity, which usually doesn't last that long. But so right now it's in divert mode, and you can see here, this is my divert, this is my battery to the left of it, this is my divert. This leads to the battery. So when it's not in divert mode, all the electricity from my solar panels and bicycle generator go through this wire here and end down in the battery, which charges the battery. When I am in divert mode, which is what it is right now, just about ready to click back over to non-divert, this right here is my divert line. See, now it's charging the battery. It's only going to last maybe 15 seconds at most. But the divert, which is right here, runs to the grid tie inverter. So right now it's in divert mode, and the energy coming into the divert line, which is right here, the charge controller, it goes through this line right here, and that runs into the back of the inverter. There's a positive and there's a negative. The divert energy, the charge controller is sending the energy through this line here. It ends up in the back of this inverter. So the excess electricity that is coming from the panels that is being diverted is ending up here. That electricity is being converted to AC current. That AC current comes out of this line, plugs into this wall outlet here, and it's only putting out 13 watts. But I took some video footage, which I'm going to be tying in right now, of the panels at their full peak output dumping energy into the grid, and it averaged about 150 to 160 watts. Which brings me to the next point, which is a disadvantage to these micro grid tie inverters. Typically speaking, they're not very efficient, and you would have to buy quite a few panels to overcome that deficiency in the inverter. Commercial grid tie inverters that basically are installed by an electrician or the energy companies that run straight through your mains are around 98 to 99% efficient. Plus they have circuitry that perfectly syncs and matches the frequency of the grid. And while these do a pretty good job of that, they're not nearly as efficient. And what I figured out with this particular grid tie inverter, even though it got excellent reviews, I'm finding that it's about 80 to 85% efficient, 85 being the best in a rare case, 75 to 80 being pretty much the range that these are running. So if my panels are pushing out 200 watts, I'm getting between 150 and 160 actual watts back into the grid. And that is one problem that these micro grid tie inverters have. They're not nearly as efficient. My charge controller converts quite literally 99 to 99.5% of the energy from the solar panels to the battery. And this DC to AC inverter is between 90 and 95% efficient depending on what kind of a load it has on it. So it is actually better for me to draw off the solar panels directly, meaning as soon as my battery's charged, turn this on, plug stuff in, use it. It's actually better than for me to sit on a charged battery and let this thing do its job. And that is kind of the downside to grid tie inverters, and the upside to actually off-grid charging with batteries. Now, another downside to batteries, you could say, is that it's much more expensive, which it is. This grid tie inverter here does not require a battery. It does not require a charge controller. You basically take whatever you have, your solar panels or whatever, you time into the back of this, and it does the charging for you. It does the conversion. It does the tracking, which I don't really completely believe, but it does its tracking to figure out, the most efficient use of the electricity, and then its output. So no charge controller needed, no battery needed, no inverter needed. So in the end, you could look and say, well, yeah, it's going to take a couple extra panels to match what this setup is putting out, but then again, you're saving a lot more money by not having the battery here. So there's valid points all around. For me, I wanted battery backup. So I have the battery here. Plus, I want to be, more efficient than what these little grid tie inverters put out. But to each their own, basically, is how it works. If you are looking for the cheapest way to save money on your electricity bill, the grid tie inverter with solar panels, definitely the way to go. Okay, for $1,000, you can get this inverter plus probably about 400 to 500 watts worth of panels. Grid tie it, off you go. So during the sun hours, you're generating between 400 and 500 watts of electricity. Or you could take that $1,000, get a single panel, get your inverter, your battery, and your charge controller, and set it up that way. So it all depends on what you want. If you want battery backup, then you're going to have to spend some more money. If you just want to save money on your electricity, meaning offset your electricity costs, you need to get the grid tie inverter if that's all you're going to do. But keep in mind, these grid tie inverters are not allowed everywhere. And if the energy company does not know that you have this and your meter is spinning backwards, and they see either the meter spinning backwards or they see that you actually used a negative amount of electricity from month to month, then they're going to question it. And I have read on various forums of people getting their electricity shut off because they have these and either refuse to, basically not use them or run into some other problems. There's also the issue that your electricity company may think that you're tampering with your meter, which in my case, my energy company, if they detect that you've been tampering with your meter, which I have not, then they will actually charge you what's called a tamper fee, which increases your kilowatt price through the roof, absolutely through the roof. Fortunately for me, I'm not tampering with my meter. I'm just not. I wouldn't even dare think about doing that. But the grid tie inverter does make the meter spin backwards. If I have a draw, then it offsets that draw. So if I'm putting out 100 watts out of this and I have 100 watts consumed, then basically the meter is stopped. And if I'm putting on 120 watts and I'm still consuming 100 watts, then the meter is going to be spinning backwards really slow. So I do have some footage, which you just saw, of the meter actually going backwards. So just keep that stuff in mind. There's a lot of people on YouTube who do this. There's a lot of people in the U.S. who do this, and you know, if it was to the point where people were getting busted left and right, we would hear about it. But the fact is that people run, you know, 4 or 5 of these at once, plugged into different outlets throughout their house, and they've got, you know, a kilowatt on the roof, and they're just grid tying back in to basically offset the cost of their electricity. They monitor their electricity usage to make sure that it never goes into the negative, and they basically just, you know, consume enough electricity to pay for this setup, basically, to zero out their bill. Again, even doing something like that, you know, the energy company may, in fact, nice ant, the energy company may, in fact, see that you've gone from, let's say, 500 kilowatts a month to 100 kilowatts a month, and then think, okay, what's going on here? Is there tampering? You know, whatever. I mean, they figure this stuff out. So you don't want to go from July using 500 kilowatts to August using 10 kilowatts, because either you were away all month long or you're possibly tampering with the meter. There's things that will trip that to get them to investigate that. And as long as you're not tampering with your meter, then you're okay. Now, if they come out, they look at your meter, and they see it spinning backwards, they may, in fact, question you. But the main reason that they don't want you to do this is because of line worker safety and line conditioning. So this microinverter here actually has a safety feature, and I'll demonstrate it here. I'm going to unplug the inverter, and as you can see there, the inverter went into fault. So I can touch this, okay? Normally 120 volts is coming out of this, okay? But as you can see here, I'm touching it right now. Nothing is happening because there's no electricity coming out, and that's the important thing, okay? No electricity is coming out of the microinverter when it's not plugged into the grid, and that's the important part, okay? So I'm going to go ahead and plug it back in. You can see here it's you know, 60 hertz. I mean, the electricity is right there, it's the same, so there's not some weird frequency going on. 120 volts, so 13 watts is what it's putting out. So the point is that when this loses the grid, it will shut off automatically. I mean, it'll completely disconnect, and you don't have to worry about getting shocked or the line workers getting injured or anything else like that. That is called islanding, and that is one of the features of this grid tie inverter. And if your grid tie inverter does not have this, then, well, I'd recommend getting another one or not buying it or whatever, because this is a huge safety issue. So on the off chance that someone were to, you know, electrician or energy provider representative were to come out and see this, then I could simply unplug it and show them by touching the 2 prongs that there's no electricity going out when it's not connected to the grid, because that's really their main concern, is line worker safety, and I completely understand. So, you know, it's kind of up to you if you want to pursue that. Maybe you can call your energy company and find out what they allow. There's different laws and rules and restrictions for different areas, so just be aware of that. For me, I'm not going to be generating enough electricity to cause any issues. I'm basically offsetting some of my electricity costs based on the surplus energy that I have. And as I add panels, of course, that surplus is going to increase. So hopefully that answers some questions regarding my grid tie inverter, why I went grid tie. And, you know, if you have any questions about these grid tie inverters, you know, feel free to ask. And hopefully you'll save some money on your electricity. So take care, guys.